Yeah, good morning my dear students. Today I am going to discuss the topic on applications of IR spectroscopy. What is the application of IR spectroscopy? The first important application is determination of one of the functional group band intensity. So how will you determine the functional group band intensity? Suppose for example if you take the hexane-hexanol mixture, how will you determine that? It is determined by measuring the intensity of absorption at 3300 centimeter inverse, because in hexanol the hydroxyl group will be there. Right, the hydroxyl stretching vibration will give a sharp absorption band at 3300 centimeter inverse, right? And we have to compare with the standard hexanol so that we can easily find out what is the concentration of hexanol present in the hexane-hexanol mixture. So simply we can say that the intensity of the band is directly proportional to the concentration of the absorbing species. The second important application is hydrocarbon contamination in drinking water, right? So how we can determine the hydrocarbon contamination in drinking water? We just go for extraction of water containing hydrocarbons with trichloro-trifluoroethane. When I extract with the water containing hydrocarbons with this particular fluorocarbons, that is trichloro-trifluoroethane, I will get the CH stretching vibration at 2930 centimeter inverse. So this is very useful for identifying the hydrocarbon such as oils, greases present in the drinking water as a contaminating agent. So this also can be identified by IR spectroscopy. The third important application is structural investigations using the various functional groups in a molecule. What is this structural investigation? The major qualitative purpose of infrared spectroscopy is to identify the functional groups in a molecule and thereby confirming the structure of the molecule. So I can give a simple example here. Let us take the example acetophenone. So this acetophenone contains benzene ring with C double bond O CH3. Now we will talk about the benzene ring. The aromatic CH stretch vibration will be coming at 3080 to 3030 centimeter inverse. You will get a sharp band in that region. Similarly, the aromatic bending vibration, CH bend vibration, will be coming at 910 to 650 centimeter inverse, as it is an out of plane bending vibration. And similarly, the carbonyl stretch vibration will be coming at 1675 centimeter inverse. And carbon, for the alkane group, the carbon hydrogen stretch vibration will be coming at 2960 to 2870 centimeter inverse. And if you take carbon hydrogen bending vibration of alkane, it will be coming around 1475 centimeter inverse, especially out of plane bending vibration. Right? So this is one of the example. Like this, any molecule, any organic molecule or any drugs whose functional groups, if you want to determine, we can easily identify with the help of IR spectroscopy. So this is the biggest application of IR spectroscopy. Now the fourth important application is we can also do the solid state analysis, which includes both the drug substance and the product. This is also is possible, right? And the fifth important application is monitoring the structural changes and identifying the compounds in situ from analyzing the crystals on a hot stage microscope to monitoring the chemical process on plant scale. So what we can do that whenever we are carrying out any reactions in the reaction vessel, if we want to monitoring the structural changes, again we can use this IR spectroscopy. Particularly we are using FTIR hot stage microscope. Through the microscope we can identify the functional groups and their changes easily. The next important application is a quantitative analysis of the multi-components. Again, quantitative analysis, even though it is not reliable, because A is equal to ABC, the absorbance is directly proportional to concentration of the absorbing species, provided the path length should remain same. But in case of IR spectroscopy, the path length of the sample cell will not remain same. Why? Because the sample cell is coated with some agents, inorganic compounds like sodium chloride, which is hygroscopic. So after some time interval, what will happen? The path length may not be same as such. So that is not a reliable method. Quantitative analysis is not a reliable method in IR, but even then we can perform the quantitative analysis for multi-component analysis using IR. How will you do that? So if you take the absorbance of the total component, absorbance of the component F plus absorbance of the component G. So A is equal to ABC, therefore AF is equal to AF BCF plus AG is equal to AG BCG. We are putting that Beer-Lambert's law formula. So small a is the absorptivity of the component F. Suppose if you want to find out the absorbance at nu 1 bar, that is at particular wave number, which is equal to AF1 BCF plus AG1 BCG. now I can find out the absorbance at another wave number V2 bar is equal to AF2BCF plus AG2BCG. Right? So this is how we can find out the absorbance in different wave numbers. Right? So this is one of the important application how we can analyze the multi-components for quantitative analysis in IR. The next important application is GCFT-IR to identify the volatile mixtures. When you want to identify the volatile mixtures, we can club the gas chromatography with the FTIR as a hyphenated technique so that we can analyze the mixtures, whatever the volatile mixture components are separated, we can easily go for identification with functional groups in IR. There is another application called characterization of coatings by ATR method. So surface technique, coating is a surface technique. So if you want to analyze the characterization of the coatings by the IR spectrometer, we are using the attenuated total reflectance spectrometry technique, a modified form of IR which is called ATR technique, where we can analyze any type of samples, whether it may be solid, liquid or semi-solid, any samples can be analyzed. Now there is another application, pre-formulation study. Particularly we can identify the drug excipient interactions or the drug polymer interactions using IR spectrometry. So I can give an example here, the drug and the excipient. The drug gives a highly diagnostic region of the spectrum clear of interference from the excipient bands. Drug means it will give only the functional group for the drug, not the excipients, right? And the excipient, if you choose the excipient, the functional groups such as carbon double bond O group not found in the excipients. Most of the excipients does not have the carbonyl functional group as such, but there are certain few exceptions. Some of the exceptions are povidone and stearic acid. They contains the carbonyl double bond O stretching vibration, right? So that most of the things we are not having, the excipients don't have the sharp absorption band or the carbonyl stretch vibration in the IR spectra, whereas the drug will be giving a sharp clear C double bond O stretching vibration in the IR spectra. So this is how we can compare whether it is a drug or a polymer. The concentration of the drug should be always greater than 1% in the formulation, particularly the active ingredient concentration should be more. Then only we can go for studying the drug excipient interaction. So this is all about the another application of IR. Now reactions, the rate kinetics also can be predicted with IR spectrometry using whether it is a slow reaction or a moderate reaction. Based upon the intensity of the functional bands in the IR region, we can identify whether the reaction proceeds in a faster manner or in a slow manner. Now there is another important NIR analysis, near IR analysis, which is having three important functions: verification of the identity of the packaged clinical supplies. And the second important application of the near IR analysis is raw material identification. And the third important application is blend homogeneity. So without opening the package, if you want to analyze like a strip package or blister package of the tablet, without opening the strip, if you want to analyze the substance with IR, it is possible. Particularly with the near IR spectrometry, it is possible. It is a non-destructive technique. The next important application is phase transformations and phase transition studies. So this is also one of the important application because IR is valid for particles greater than 125 micrometer, lesser than 590 micrometer. If you want to study the molecule, the particles, particularly in IR spectrometry, the particles size should be greater than 125 micrometer and it should be less than 590 micrometer. Within this range, you can study the particles in a thorough manner for their functional group. Before last, we will be having another important application, chemical mapping and imaging techniques. So this is also imaging techniques. With the help of FTIR stage microscope, we can perform the imaging techniques as well as chemical mapping also can be done. And last important application is polymorphism studies. When we talk about the polymorphism studies, we talk about two important forms. One is the crystalline form and the other one is the amorphous form. Particularly the crystalline solids are giving the fine spectra because the crystalline solids are having a perfect geometry of arrangement, right? So what will happen? They have the lesser energy and therefore they will be giving a very fine spectra which is very, very narrow and easy to identify. Whereas in case of amorphous solids, they are having more randomness. So what will happen? They give more and more broadening of the spectra, right? Spectral broadening will be there for the amorphous solids. This is the way we can segregate both the crystalline solids and the amorphous solids. I hope you understand it in a clear manner. Thank you, my dear students. Thank you very much.